So here's the data analysis of the lab. So if you can follow along, we took the nut. The initial mass was 5.09 grams. And then I weighed it at the end, and it was 4.43 grams. If you subtract those two, 5.09 minus 4.43, what happened was we had 0.66 grams of mass loss, but it actually wasn't lost. That was actually used up and burned in the process. And what it did is it heated up the water, and we need to calculate that temperature. So I was rattling off a bunch of numbers, and here are the numbers. The first rise was this temperature increase, the second one was this, the third was this, the fourth was this, et cetera, et cetera, et cetera. So I took the differences between the temperatures of all those rises. So if you remember, it was going up and down like a roller coaster, and I was taking the temperature change between here and here, and I was looking at where was the heat going into the water. And I added those up all together, and I got 54.78 degrees Celsius. So the temperature change of the water was 54.78 degrees Celsius. So the question is, how much heat was released from the nut? Well, the heat that was released from the nut was the heat that went into the water to heat it. And we know how much the water was heated. So we've already subtracted the mass. We have this right there. And we already highlighted those slopes right there. And we recorded the degrees Celsius. So now what we're going to do is we're going to estimate the calories in the food sample. We'll need to know the mass of the water that we heated. Well, we heated 50 milliliters, and we know that the density of water is 1, so 50 milliliters is going to be 50 grams. When you convert that, it's going to be 0.050 kilograms. So now we can determine the amount of heat absorbed by the water, which is the amount of heat that was lost from the nut. Using the formula, heat is equal to mass times the specific heat times the temperature change. So if we can do this, the mass of, not the nut, but the water sample, the amount of heat that was absorbed by the water is the same that was lost by the nut. So the mass of the water is 0.050 kilograms. The specific heat of water is down here. The specific heat of water is 4180 joules per kilogram, degree Kelvin or degrees Celsius. We used Celsius, and it's going to be the same. So the kilograms will cancel. And now we're going to be multiplying by the change in temperature. The change in temperature was 54.78 degrees Celsius. Degrees Celsius, degrees Celsius. When you multiply 0.05 times 4180 times 54.78, we get 11,450 joules. So let's put that up here. We have 11,450 joules. So now what we're going to do is we're going to take that joules and we're going to convert that into kcals, or calories. These are actually the same value. So since 1 kilocalorie is equal to 4180 joules, we can use the following formula. So we use the joules from the example, and 1 kcal is going to be equal to 4180 joules. And again, 1 kcal is going to be 1 capital C calorie in food. So the joules from the prior example, we have 11,450 joules. We're going to multiply this by 1 calorie in my food is going to be equal to 4180 joules. So what happens is this, we're going to take that number 11,450 divided by 4180, and we're going to get 2.74. The joules cancel. Now we have calories. What that meant is that during this process of the nut burning, it released 2.74 calories. And we actually didn't burn the entire nut, just so that gives you an example. That will give us about that little amount that burned, the half of it that burned, whatever it was, 2.74 calories. So let's put that into our chart here, and that's going to be 2.74, and it's going to be 2.74 calories and kcals, because those are going to be the same. You need 1,000 of the little calories. Okay, 1 little calorie is equal to 4.180 joules. So 1,000 calories, or a kcal, is going to be equal to 4180 joules. And a kcal is also equal to a food calorie. So this here is a food calorie. Meaning, again, we burned off 2.74 calories. But what is it calories per gram? And that's what I want to figure out. So I'm going to take my answer, 2.74, and I'm going to divide by what was the mass of the sample that was actually burned. I don't need to know the initial mass of the sample, meaning I don't need to know the mass of the nut. What was actually burned? We lost 0.66 grams. So if we divide this by 0.66, because we want the calories per gram, this is the calories that was released per gram. And we get 4.15. 4.15, and that's going to be calories per gram. What I want to do now is I want to share with you a picture of the nuts. And if you eat a 1 ounce serving, or about 15 pieces, okay, you'll be eating about 28 grams of nuts. And you would be getting 160 calories from that. So what is the calories per gram according to this? The calories, well, we have 160 calories. Okay, here's the calories divided by the 28 grams that was used. So if you ate that nut, how many calories would it actually produce per gram? Well, we got 4.15 calories per gram. And let's do the calculation. 160 divided by 28 is equal to 5.71. So we have, in this, we have 4.15 calories per gram. This is the experimental. If you look at the food label, the label says that you will get 5.71 calories per gram. So we should have gotten more heat to heat up the water. Why did not we get more heat? We should have gotten 5.71. We got 4.15, which is actually fairly close. But why didn't more heat not go into the water? The reason why this is a little bit low, this is usually lower than what we get here, because when they do calorimetry experiments and they burn that nut, they burn it inside of a container that completely retains the heat. So our value was a little bit low. Why was it a little bit low? It's because the heat, where did the heat go? The heat went into the water, but the heat also goes into the surrounding air. And so we couldn't calculate for this. But what we did calculate is for the amount that went into the water, and we could quantify that, and we got pretty close. 4.15 divided by 5.71 is about a 73%. We got 73%. So we got about 27% error, but we claimed about 73% of our calories. And that's pretty good for this type of experiment.